Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Till now we have learned how to find the dimensions of a derived physical quantity by converting the derived physical quantity in terms of a base quantities. In our today's class, we are going to learn how to find the dimensions of a some important constants. Dear students, as you know that in order to define the physical aspect or the behavior of any object or material in physics, we used variables or constants. It means that in order to understand the behavior of any object, variables are very important and physical among different types of physical relation we got some constants. According to dimensional analysis, variables are of two types. Some variables are dimensional less and others are dimensional variable. As we discussed the derived physical quantities in our previous videos, all are dimensional constants like work, power, force, acceleration, velocity, etc. All are dimensional quantities or variables. Constants are also categorized into two types. Some constants are dimensional less constants and some are dimensional constants. In our today class, we are going to find or learn the dimensions of a constant which is known as gravitational constant. There are so many dimensional constants like mm, gravitational constant, Planck's constant, gas constant, coefficient of coefficient of viscosity, etc. All are dimensional constant. Other dimensional constants are also there, but we mention here only few of them. Now let's learn how to find the dimensions of gravitational constant, which is represented by capital G. As we see this constant in our school physics, in Newton law of gravitation, which is F is equal to G m1 m2 divided by r square. Here force is the force of attraction between two masses. G is the gravitational constant, r is the distance between two masses, and m1 and m2 are the masses of the object. So in order to find the dimensions of a G, we rearrange this mathematical expression as G is equal to Fr square divided by m1 m2. Now we insert the dimension of all the physical quantities involved in this mathematical relation. Dimensionally, the force is represented by mlt minus 2 as we learned in our previous videos, and dimensionally length is represented by capital L with a square on it divided by m1 and m2 are the masses, and dimensionally mass is represented by capital M, and we got a square on it because there are two masses. Now we express all of these dimensions in a one square bracket, that is m1 minus 2, this 2. When we shift this quantity from denominator to numerator, we got a minus sign. L1 plus 2 and t minus 2. Now m minus 1 L3 t minus 2. This is the dimensions of gravitational constant. In the same way, by following the same procedure, we are able to find the dimensions of other constants like Planck constants, gas constant, coefficient of viscosity, etc. Inshallah, in our next videos, we are going to find the dimensions of some other constants, and it is a humble request to all the viewers that like these videos, share it, and subscribe our channel so that we can find more videos which will be helpful for understanding the concepts of physics. Thank you very much.